Hello students, my name is Shayan Mitra. I'm the faculty member of Department of Electronics and Communication Engineering, Greater Kolkata College of Engineering and Management, JIS. Today I'm going to take the class of Embedded System Design. The subject code is EC704B and this is the lecture number 19. In the previous lecture, I have described the RTOS different kind of time stringent advantage and disadvantages of RTOS in this and what is the basic difference between multitasking and multi-threading. Probably I have described only multitasking and today I am going to describe the multi-threading process. Okay, so let's begin with the class. So this is so let's start with the multi-threading. What is the multi-threading? The definition has said here that a single program or application can be written so that it can be executed as two or more threads of instruction. A thread can be thought of as a standalone task. For example, in a video processing application, the video information could be processed as one thread, the audio as another. So in case of video processor application, the video processing application is a total application, and the video processing and audio processing can be considered as a video processing can be considered as a standalone task which can be said as a thread, and the audio processing also can be mentioned as a standalone task which also be a thread. It means basically if we split an application into different kind of tasks, it is known as thread. But in case of multitasking, what will happen, we use different standalone programs for process. So that is known as multitasking, and particularly this is known as multi-threading, where we are splitting an application into two, three more, or could be many number of tasks. So all these are known as threads. Suppose video information application is a specific application. Now that application has been divided into one as a video processing and another one as an audio processing. So both of them can be individual known as a thread. So let's go to the next step. So this is the thing of multi-threading. So through this picture we can easily understand that what is the basic difference between a multitasking and a multi-threading. In case of multi-threading, so in case of multitasking, we have two different applications, two different programs, and according to the instruction set that we are fetching, we use the processor to we are using the control switch to balance the program. That suppose we want to run the program 1, so the program 2 will be in a idle state, and when we switch to the program 2, the program 1 will be in idle state. So to use of all this processor in an optimized way is the basic aim of ours. So that's why this is the basic difference of multitasking and multi-threading, and that has been so in case of multi-threading, what will happen, there will be a single application that has been running, but we have divided the whole application into 2, 3 or more than 2, 3 tasks. So these are known as threads, but these are also would also work as a multi-level processing system. Okay. But yes, the same kind of features are being used here to understand what is the multi-threading is. So let's go to the next slide. So multi-threading of video processing is the application thread 1 is processing a video and thread 2 will process the audio. So after the processing of two different processor, we will get the output as a video and audio, and the video and the audio and the video. So after getting the application, after applying the processor on this thread, we will get the output, and after merging them we will get the total application. So we are processing the specific application is known as video processing application, but in a different way, where we just split the big application into 3 or 4 sub segments. Those segments act as a task and are also known as a thread. So this is called multi-threading, and the previous one where we use the concurrent process to respond to the task those are, or response to the mock draft, those are known as multitasking. So let's go to the next one. Now threads. Threads occur within a single application that we have already discussed here. The application must be written for multi-threading. That's a very important factor. Suppose we just suddenly just out of thin air we can't just create a multi-threaded application. Now to be specific, if we want to have multi-threading application, we need to write that multi-threading application according to that. Suppose we didn't create or write the application according to the multi-threading process, but we want to try that on the processor. It is probably a bad decision. It could probably a bad decision. So third one is, not all applications lend themselves to this form of parallelization. So threads occur within a single application that I have already discussed. The application must be written for multi-threading. So third one is, not all applications lend themselves to this form of parallelization. So that's both the second and third point are basically counterpart of each other basically. So the application must be written for multi-threading, and that's why it has been easily understandable that not all applications lend themselves to this form of parallelization. But parallelly two tasks are performing, where the two tasks basically systematically part of a big application. The fifth one is, the processor must support multi-threading. Also, that's an important part. The processor must support the multi-threading process. Not all processors do. So these are the basic important part that we have touched here. So let's go to the next one. So here is an example of Pentium 4, which was optimized for multi-threading. That's why the concept of code to duo comes. Now, suppose this is a Pentium 4. So this Pentium 4 processor basically designed for multi-threading. Now how it works? Suppose there is a big application. Now we have split the application into 3-4 threads, or basically 3-4 standalone tasks. So perform that task. As we already know that in the case of when we are trying to understand the multitasking, we have realized that basically it probably looks like that processor depend upon parallelization in case of multitasking, where both the application or both the program is running simultaneously. It supposedly looked like in a physical world, when we are experiencing all those application software in our life, we don't get to understand that the time taken by all these operations are so fast that it is impossible for us to understand that how much time it has been taken. Basically, it's worked in a millisecond, a microsecond format. So in the multitasking, we have already understood that it's basically a concurrent process. So using the control switching, we, as according to, if suppose we need, we're driving a car, now suddenly I want to open the window. So what I will do? I will switch a button. Now in that time, the task that is in idle state, the processor control switch will go to that task. The task will be completed, and again it will come to the now all this process that I am describing here, that suppose that one process is going on, and suddenly I just switch the control and we just move it to the window, and the window shutter will just open, and I just go back. But the game is going on. Okay, so basically the whole thing, the whole process that I have been describing right now, it basically happens in a microsecond. So it is tough for us to distinguish between these two tasks. The amount of time that process one has been in idle space, the time amount will be microseconds. So it is impossible to predict. Okay, so these are the differences. So now let's come back to the point that we are discussing here, that multi-threading. Now in case of multi-threading, the same thing, that one application divided in many tasks. Now if you want to process a task, okay, anything, process a task, what will do? We will feed it to the processor. Now if the processor is not being structured in a way where the multi-threading is possible, in case of multi-threading, what will happen? Simultaneously, a form of parallelization will took place, where both the thread will work simultaneously. For that, we can't have a single processor. So that's why we have divide or split the basic Pentium 4 processor in two parts. The first part is known as Core 1 and the second part is known as Core 2. That's why the Pentium 4 is also known as Core 2 Duo. Duo means 2 and Core means 1 and Core 2. In Core 1 and Core 2, those are basically the same part of processor, but basically it's a segment. So in a segmented format, the first thread will go into the Core 1 and the second thread will go into the Core 2. So both the application, both the task will be executed. Okay, and the result will be get out of the single output, the thread 1, thread 2, and thread 1. So this is the process where both the thread are executed simultaneously and the output will come according to that. So that's why that is the basic differences when we are saying the Core 2 Duo, which is specifically designed for multi-threading. So let's go to the next slide. So this is the Pentium D, Pentium 4. If you take a close look, this is the Core 2 Duo format. This is the Pentium 4 and this is the Core 2 Duo format. Okay, so up to this we have understood multitasking. Two types of multitasking, like cooperative and non-preemptive, means preemptive and non-preemptive. We have also discussed with we have a discussion about multi-threading. And now after completing both the part, we are going to come to the last segment, that is multiprocessing. What's the multiprocessing and what is the difference between the multitasking, multi-threading and multiprocessing? So a multiprocessing is a single computer runs two or more separate programs at the same time. Separate programs at the same time. Servers and workstation achieve this by using multiple processors in separate packages. PCs achieve this by using the multiple cores in a single package. So that will be a revolutionary invention of Core 2 Duo, in which we using the multiple cores in a single package. The PCs achieve this by using multiple cores in a single package. By doing that, it just basically the PC will go much faster. It will become much more faster. Okay, it will go much more faster. So how it works, now we are going to understand how the multiprocessing works. A single computer runs two or separate programs at the same time. So let's go to the next slide. The types of multiprocessing. The symmetrical multiprocessor, the operating system assigns tasks as it sees fit. Asymmetrical multiprocessor, the program designer chooses the processor at the time the program is written. So the first one, the operating system assigns tasks as it sees fit. If the operating system thinks that this task is fit, then it will be sent. This is the symmetrical multiprocessor. And in case of asymmetrical multiprocessor, which is known as, the program designer chooses the processor. The program designer chooses the processor at the time the program is written. Okay. So according to the program, the processor has been selected, is selected. So these are the types of multiprocessing. So multiprocessing, single computer runs two separate programs at the same time. That is important. Program at the same time. So let's go to the next one. Dual package, dual core. So the dual package, this is CPU IC, real core CPU IC. Dual package, we have sockets 2, sockets 1, dual core. Heat sinks in dual package 2, dual core heat sinks 1, fans 2, fans 1, fan cable 2, fan cable 1. These are the dual package versus dual core basically comparison. So it is further important, but it just gives you the overview of what is really happening. Okay. So let's go to the next slide. Okay. So this is the enter the Core 2 Duo process. So because the Pentium D was made up of two Pentium 4 cores, Pentium D was made of two Pentium 4 cores. Okay. It was not optimized for dual processing. Okay. Intel redesigned the architecture of the CPU, optimizing it for multiprocessing. The The result is called core architecture. Apparently, this is new name that replaces Pentium. Okay. One of the early processors to use this new architecture is the Core 2 Duo. Well, that we have already discussed what is Core 2 Duo means and why the Core 2 Duo has been used. Okay. So we have understood here that because the Pentium D was made up of 24 cores, it was not optimized for dual processing. Intel redesigned the architecture of the CPU, optimizing it for multiprocessing. The result is called core architecture. Apparently, this is a new trait name that replaced Pentium. One of the early processors to use this new architecture is the Core 2. Okay, so let's go to the next one. So this is the design of a Core 2 Duo. Okay, this one is a Core 1, this one is a Core 2, and unified A2 cache. It means basically both the core has one unified cache. So the data fetching will be faster, and the task will be also be performed much more faster. So this is known as Core 2 Duo design. This one is Core 1 Core, and unified A2 cache. So let's go to the next one. The Core 2 Extreme, the fastest of the Core 2 Duo series, is the Core 2 Extreme. Allows overclocking, a technique that allows users to run the CPU. Allows overclocking, a technique that allows users to run the CPU at a higher clock speed than the manufacturing requirements. Okay, so that's a very important factor. The fastest of the Core 2 Duo services allows overclocking, a technique that allows users to run the CPU at a higher clock speed. Okay, than the manufacturer requirements. So that's why it's known as overclocking. So this is the Core 2 Quad. Now how it works? Now this is the first Core 2 die, and this is the second Core 2. Okay, so this is known as Core 2 Quad. That's why it is known as Core 2 Duo. It means 2 core. These are Core 2 Quad, means 4 segmented code has been selected. Now one task can be applied, one application can be it will go much more faster because it could be split itself into 4 different threads, and all those threads will be fed to the processor and will be a easy peasy result. So it means that as we increase the multi-threading, if we increase the multi-threading, if then all the application or all the program that has been written to do that, if the hardware architecture helps, that we can perform that, we can create the better amount of speed. So let's go to the next one. And first one is the first Core 2 Duo, this second Core 2 die. The fourth one is the Core 2 Quad, is a single Core 2 Quad die. Okay, so the Core 2 Quad is this, and single Core 2 Quad die is that. Okay, so this is the Core 2 Extreme. Okay, so after this we have discussed what is multitasking, what is multiprocessing, what is multi-threading. So it is a multi-threading or it is a multitasking. Because multitasking, what will happen? We have two different programs and we concurrently get executed. That is multitasking. Now, if you consider the multi-threading, what will happen? That there is a single specific application that is being processed, suppose the video processing. Now, we just split it into two different segments, or that is known as threading. Now, if we want to have a video processing system, we want to process the video and the audio, so we will put them in two different tasks, and according to that we perform that task. We need that kind of architecture that has been first introduced in the India, that is the Core 2 Duo. So as you have already know, the tasking is a concurrent process just because of the amount of time is very few, so that is impossible to understand. Okay, so in case of Core 2 Duo, that core will help the threading process to be fulfilled or successful. So first one is multitasking, the concurrent process. Second one is a multi-threading, where we have different number of tasks. Basically, it has been split from one application. So process all those things we need to, as we have two code. So the two different tasks will be fed to a single, basically two different code, and both the code are part of a specific process. Okay. So So this is known as code to go, and the result will be satisfactory at all. And the last code is the multiprocessing. Now if we just discuss the multiprocessing here, is that the multiprocessor is a single computer runs two or more separate programs at the same time. So it is a multiprocessing. Separate program will be run at the same time. But in multitasking, separate program will not run at the same time. It will be concurrent. That's the basic difference. In the multiprocessing, a single computer runs two or more separate programs at the same time. Okay. So this is multiprocessing, another one is multitasking, and another one is a multi-threading. So this way we think we are going to end this lecture. We are going to conclude this lecture at this point. But from the very beginning of this module 4 lecture, we have started the lecture 14. This is 15, 16, 17, 18, 19. In the lecture 14, we have discussed, we have started with operating system, RTOS. We have understood what is the kernel, we have understood multiprocessing, multi-threading, multitasking, how the task synchronization works. There are many different things that we have worked on. So, the next lecture, we will understand different kind of DFG model. So, okay, thank you.